The source in this test is simply a commonly available non-shielded electric extension cable. Under this wooden plate I placed plastic boxes with no metal on them, because metal could mess up this test. The lines are to make it easy for the viewer to see at what distance we will be at. The grey lines are 1 foot apart, middle to middle. The white and blue lines are 4 inches apart, middle to middle. I will simply move 2 devices adjacent to each other from this end towards the extension cable. I will do this over and over again, so that we can see which devices are the most sensitive to electric fields. For the Sempratec, the orange device, you look at the middle column only for electric. The bottom LED doesn't count, that one always burns, so the device has not picked up something yet. The Sempratec starts picking up here, at the black lines. The 1130 has still not picked up yet. The Sempratec is the better choice of these two. The 1130 only starts picking up very close to the source, so this device is very insensitive. Next comparison. Again, for electric, only look at the middle column on the Sempratec. There is kind of a delay in the reaction of its LEDs. The manual of the Sempratec claims that it performs a new detection every 2 seconds. You will like this or dislike this. I dislike this. There are other devices that do better things. The green device only picks up very close to the source. So the Sempratec is the clear winner in this test. As we have seen, the cornet's lowest point is not 0, and it jumps around. It's wonky. This makes it difficult to read and see when it starts picking up. Both devices seen here do not have a sound function for electric fields. You will see 8 volt per meter just about now, but it's difficult to know what the cornet measures exactly. The accuracy and overall performance of the electric mode of the cornet is not so good. There is no clear winner for me between these two devices, so I'll leave this one for the viewer's choice. The Cornet can measure higher fields though. The Semprotec will max out quicker. The Trifield's electric mode starts at 0, the peak as well. The Trifield's values respond real-time, and it has an extra function for providing feedback called peak hold. The response of the Semprotec is a bit comparable to the peak hold of the Trifield. The peak on the Trifield starts picking up right about here. The Semprotec doesn't have a sound function for electric. The Trifield has a sound function, but it's not a true sound function. The Trifield measures about 8 volt per meter when the Semprotec starts reacting and shows 6 volt per meter according to the manual. The Trifield is more sensitive to low electric fields than the Semprotec. For electric fields, the Trifield is more versatile and more sensitive. The Trifield has a more likable starting point. The ticking sounds come from the Trifield. It always ticks a bit even when it measures nothing. The Cornet doesn't have a sound function for electric. The Trifield's sound function is not a true sound function, but its sound function can be useful. The Trifield has a more useful electric mode than the Cornet has. Both devices claim to measure up to 1000 volt per meter. The Trifield claims to have a slightly wider frequency range for electric. 40 Hz up to 100 kHz versus 50 Hz up to 50 kHz for the Cornet. The EMF 390 already picks something up here, you would think. The EMF 390 has three ways of electric field indication. A needle, a level bar on the left, and numbers that change every 1 second or so. For easier reading, I guess. So the EMF 390 is more sensitive to low electric fields. The Sempratec doesn't have a sound function for electric. The EMF 390 has several sound functions. Some are annoying and none of them is a true sound function. Both these devices have a wonky lowest point in electric mode, but the Cornet has the worst. I don't trust the EMF 390 below about 1.3 volt per meter. And I don't like using the Cornet for electric measurements. At about this point, I think the EMF 390 starts to be more useful. This EMF 390 has a more sensitive and more useful electric mode than this Cornet. But the manual of the Cornet is honest, because it says that it starts to be useful from about 10 volt per meter. As often, the EMF 390 jumps around a bit at its lowest point. So what do we measure exactly? 0.2, 1 or 0.6? Both these devices have a sound function for electric fields. But both do not have a true sound function. Not for anything. The peak of the drive field starts to pick up about here. The EMF 390 has a level bar and a needle. This is useful because the numbers of the EMF 390 are updating slow. But this makes reading the value easier. Without a level bar or needle, I would not have liked this, but because of those, it's okay, I guess. The tri-field has a peak hold that is updating slow, holding the value, making it easy to read. The big numbers on the tri-field update fast. I would have made that thin peak hold on top of the level bar on the tri-field a bit thicker, making it a bit easier to see. It's not that easy to point out a winner, because the EMF 390 is not that great for the lower electric fields. What does the EMF 390 measure? 1.1, 0.4 or 0? The Eric Hill starts picking up about here. Both these devices have a sound function for electric fields, but both do not have a true sound function. The Eric Hill looks stuck at 4 volt per meter for some time. And then it suddenly starts going up fast. The EMF 390 jumps from 3.5 to 10.5, even though I'm practically holding position. The Eric Hill looks stuck again at 12 now, until I moved a lot forward. Both devices are not perfect, but both have a fairly good sensitivity to low electric fields. This will be a quick run-through. I think it's very clear that the EM Fields PF5 is the clear winner. I like the fast response from the LEDs on the PF5. The Eric Hill starts picking up about here. Again, the Eric Hill looks stuck at 4 volt per meter for a moment. I like the PF5's response more. I find the PF5 a very easy and satisfying device to use. The Eric Hill has an annoying beep sound function, but it can be turned off permanently. The PF5 does not have a sound function. The PF5 is maxed out quicker than the Eric Hill, but this isn't really a problem because normal people want low fields. The EMF 390's lowest point is behaving a bit different again compared to the previous tests. The PF5 is showing us 5 volt per meter, while the EMF 390 measures about 1. You can see that the PF5 reacts very quick when moved. I like this a lot more than what the Semprotec did. The PF5 looks very stable and reliable. The PF5 doesn't have a sound function. The EMF 390 has several sound functions. Its beep sound function is the least annoying one, and it does not have a true sound function. The EMF 390 can measure stronger fields than the PF5. The PF5 maxes out at 200 volt per meter. But most people are interested in low EMF, so for those people this isn't really important. Another quick run through. Both devices have a sound function for electric fields, but both do not have a true sound function. I think it's clear that the performance of the 1130 is very weak. Even super close to the cable, the 1130 measures nothing, when pulled back just a little bit. Both devices have a sound function for electric fields, but both do not have a true sound function. And the design of the sound function of this white device is more likable. This green device is also a very insensitive device. Only when I touch it with my hand and bring the tip closer, it starts measuring something. The lowest point of the white device here is 0. It has good sensitivity, detail, stability and reliability. The orange device measures 6 volt per meter, where the white device measures about 21. The white device clearly has a more sensitive and more likable electric mode. As we have seen, the Cornet's electric mode is wonky at its lowest point and doesn't go to zero. The ME analyzer started at 0 and is very stable, sensitive and progressive in measuring lower electric fields. You can see the values on the ME analyzer rise with steady progression, easy to follow. The ticking sound comes from the tri-field. I wish it didn't tick when there is no EMF, like how the ME analyzers do it. The peak on the tri-field starts picking up when the white device is at about 5 volt per meter. When the tri-field measures 1, the white device measures 8. Both devices have a sound function for electric fields, but both do not have a true sound function. The white device is the winner in this comparison. The performance of this white device lowest point looks more stable and reliable. Both devices have a sound function for electric fields, but both do not have a true sound function. The green device is performing very poor. I cannot recommend it. I'm switching to another mode here, so that the values can go higher on this white device. The green device only starts reacting when I touch it with my hand. Another fast run-through. Both devices have a sound function for electric fields, but both do not have a true sound function. The 1130 has a very poor performance. I cannot recommend this device. I'm showing you here that I'm setting this device to its highest sensitivity. With this greeny device, you will only know if you reached a certain threshold. This device is also very annoying to use because of the loud beeps that cannot be turned off. This white device starts at about 1.3 to 1.6 volt per meter in this mode. I dislike its starting point, but you can see that it provides a very detailed measurement. This starting point downside of this white device is easy to fix by connecting the ground cable that is provided with it. The Eric Hill, on the other hand, jumps from 1 to 4 over a very short distance. And then the Eric Hill hangs on 4 for almost 8 inches. All while the values on the white device rise with fine detail. The Eric Hill is stuck again, almost for 8 inches again. The annoying beep on the Eric Hill can be turned off permanently. Both these devices here have a wonky lowest point. For this white device, this can be fixed with the ground cable that comes with it. Once we get past 2 volt per meter on this white device, it provides great detail and stability. Both these devices have a sound function for electric fields, but both do not have a true sound function. This white device remains stable at 20 volt per meter, while the EMF 390 jumps between 16 to 22. The PF5 cannot measure below about 5 volt per meter, but it's a likable device. The LEDs on the PF5 look like they indicate very similar to what this white device is measuring. The PF5 does not have a sound function. This white device has a likable sound function, but it's not a true sound function. Both devices max out here at 200 volt per meter. But if you flip a switch on this white device, it can measure up to 2000 volt per meter.